Question 4. This question is about alkanes and alkenes. Part 1. But1ene belongs to the alkene homologous series. Members of the same homologous series differ from one member to the next by CH2 group and have similar chemical properties. State two other characteristics of a homologous series. So the two other characteristics we can write same functional group, and we can also write same general formula. Other than this, there is one more. You can write that too, gradual change in physical properties. Okay, next part B. Figure 4.1 shows the displayed formula of but1ene. Part 1. Explain how figure 4.1 shows that but1ene is unsaturated compound. So the word unsaturated, it is another name of alkene family. And alkene means a compound that has carbon to carbon double covalent bond. So in the above structure, if you see, there is a carbon to carbon double bond. So we can write there is a carbon to carbon double bond. Okay, next part 2, give a structural formula of but1ene. So students, basically the structural formula means you don't have to show any bond in between them, only the double bond, okay, not the single bond. So starting from the left hand side, we have to write CH3. It means I'm talking about this carbon. And then next we have to write CH2, and next to it we have CH, and then we have to show a double bond, and next CH2. So this is how we write the structural formula. Next part 3, draw displayed formula of an isomer of but1ene. So the word isomer is a terminology. It means a compound that have same molecular formula but different structural formula. It means the above structure is showed by the examiner, which is the displayed formula for but1ene. So we have to draw another structure of but1ene, but the formula should remain same. So we have two options: either change the position of the double bond. Currently it is between carbon number 1 and carbon number 2. So you can shift the position of the double bond to carbon number 2 and carbon number 3. Or you can make branch. Totally up to you. So let's suppose I decided to go with the changing position of the double bond. So first draw four carbons atom connected together, and then shift the position of the double bond between carbon number 2 and 3, and then fulfill the valency of the carbon atom. Every carbon atom can form four bonds. So three more. The second carbon needs one, the next carbon needs one, and the last carbon needs three more bonds. So now fill with the hydrogens. So this is the another isomer or the displayed formula for the compound but1ene, which is called but2ene. Or you can make a branch. Branch means connect three carbons together instead of four, and then make a double bond, and to the central carbon make a branch like this. Always try to draw the basic skeletal formula and then fulfill the valency of the hydrogen atoms. So starting from my right hand side, the first carbon needs two more bonds. So two lines. The second carbon is already bonded to four. One, two, three, and then four. So there is no need to put any other bond. The third carbon needs three bonds, and the branched carbon also needs three bonds. One, two, and then three. Now you can write the hydrogens in front of each bond like this to complete your structure. So there are two options for this answer for the displayed formula for but1ene. Now let's move to the next part. Part C, undecane. The formula is mentioned C11H24 is present in the kerosene paraffin fraction from the distillation of petroleum. Part 1, give one use of the kerosene paraffin fraction. This is from the learning part. So the paraffin is used in jet fuel. Okay, part 2, when undecane is cracked, means it is breakdown, shorter hydrocarbon molecules are formed. Construct the symbol equation for the reaction in which undecane is cracked and the only products are butane, propene, and then ethene. So the product's name is mentioned by the examiner. So on the reactant side, we will write C11H24 as this formula is already mentioned in the statement. It is written here C11H24, and when it is cracked, it means now we have to make an arrow and write down the products side like butane, propene, and ethene. So the best way, if you don't know the formula for the butane, you can apply the general formula. So for the butane, I can write here the general formula is CnH2n plus 2. And how do we know that the formula is this? Because first we have to recognize the family. So it belongs to the alkane family. And but means 4 carbon. So replace the N with 4 like this and then simplify. 2 into 4 is 8 and 8 plus 2 is 10. So the formula for the butane is C4H10. And then for propene and ethene, they both are ending with the name ENE. So it means they belongs to the alkene family. And the formula for the alkene family is CnH2n. So prop means 3 carbon. So replace the N with 3. So it will become C3. 2 into 3 is 6. So the final formula is C3H6 like this. And you can follow the same for the ethene. Ethene means 2 carbon atom. So the formula would be C2H4. And then we have to balance the equation. So if you carefully look into the balancing part, so we can write 2 here with ethene to balance the whole equation because we have total 11 carbons. So if I'm writing the 2 here on this side, it will become 2 into 4, 8. 8 plus 3 is 11. So it means in this way I cannot balance the equation. So it means I have to remove the 2 from C4H10. If I write the 2 with the 3, the propene formula, so 2 into 3 is 6, and then 4 plus 6 is 10, and then 10 plus 2 is 12. It means this is also the wrong. So that's why I put the 2 in front of ethene. So this is the final answer. C11H24 arrow C4H10 plus C3H6 plus 2C2H4. Now the next part D, propene. Propane reacts with chlorine to form chloropropane and one other product. So C3H8 and Cl is actually substituting the hydrogen atom, means it is replacing one hydrogen atom from the compound. So the it is a substitution reaction. How do we know that it's a substitution reaction? First of all, by looking into the chemical equation. And the other thing is the word ane is mentioned, the propane family. And this family means we are talking about alkane family. And alkane family undergoes substitution reaction. So the side product for the substitution reaction is hydrogen chloride, HCl. Examiner use the word name. So again, we will write the name of the compound, hydrogen chloride, as the correct name of this compound. Now part 2, state the essential condition for this reaction. So the condition for the substitution reaction is UV light. So we will write this as our answer, ultraviolet light. Okay, next, part E, ethene react with bromine at room temperature. So this is the alkene family. and the alkene family undergoes addition reaction. Addition means a reaction in which only one product is formed. So this is also an important definition of this part. So the information is figure 4.2 shows the displayed formula of the reactants and the product. The chemical equation is mentioned in the form of displayed version. Calculate the enthalpy change. It means we have to calculate the delta H, the energy change during a chemical reaction in kilojoule per mole. Use the bond energies in the table 4.1. So the formula for the delta H is reactant minus product. In other words, I can say that bond breaking minus bond forming. So whatever the energy is involved in the bond breaking, add all the energies and same goes for the product side and then subtract. So in the first step, we calculate energy associated with bond breaking. Okay, so on the reactant side, we have carbon to hydrogen bonds. So first I will write the carbon to hydrogen area. So the energy for the carbon to hydrogen is 413. So the energy 413 multiply. We have to see how many carbon to hydrogen bonds are there. So 1, 2, 3 and then 4. So there are total 4 carbon to hydrogen bonds are there. So 4, 1, 3 into 4. Then plus other than carbon to hydrogen, we have also one bond, carbon to carbon double bond, and that is only one bond. So we will write that the energy for that is 612. 612. We don't have to multiply with any number because this is only one bond present. Next we have bromine on the reactant side. Br bond Br. So the energy for the Br is 193. Again, no number is written before bromine, so only 193. So if we add them all together, so the answer would be 2457. Now the next is we have to calculate the same thing for the product side. It means energy associated with bond forming. So if you look into the product side, we have carbon to hydrogen 1 and then 2, 3 and then 4. So total 4 carbon to hydrogen bonds are there. So 4 1 3 into 4 plus the next energy is carbon to carbon single bond and there is only one carbon to carbon single bond and the value is 347. So plus 347 plus next we have carbon to bromine bonds. So there are total 2 carbon to bromine bonds 1 2. So we will write 2 into the energy is 290, so 2 into 290. So the answer is 2579. So in the last step, we'll apply the formula for the enthalpy change, which is delta H equals to bond breaking minus bond forming. So the bond breaking is 2457 minus bond forming, which is 2579. So the answer is minus 122 kilojoule per mole. So this is the answer. So we will write the correct answer here minus 122. So this is how we could calculate the enthalpy change by using the formula reactant minus product. Now the last part of this question is part 2. Describe the color change when a sample of excess ethene means alkene is added to a few drops of aqueous bromine. So aqueous bromine is orange brown. When it added to alkene, the double bond will broken down and it will form alkane, means a substituted alkane. 1,2-dibromoethane. So there is a color change. It turns from orange to colorless.